Next example. Use spherical coordinates to evaluate integral where the G is a solid between two spheres of the radius 1 and radius 2 in the first octant. First, I want to find the limits for the rho. From the first sphere, we got rho square equals to 1, which gives rho equals to 1. From the second sphere, we got rho square equals to 4, rho equals to 2. So rho is changing from 1 to 2 in order to cover the G. Theta, because of the first octant, projection to the xy plane will be showing that theta should be from 0 to pi over 2, and phi from 0 to pi over 2, because when point falling to the z-axis, phi will be 0. When point falling to the xy plane, phi will be pi over 2. Okay, we found the limits for theta phi rho. Then we can calculate our integral. Here what we do, we replace x, y, z by their values in spherical coordinates and limits according to our calculation in the previous slide. Then we can collect the cosine theta, sine theta function, which contains theta, which contains phi, which contains rho separately. Then we have to calculate three iterated integrals separately. So first one I denote by I1, second one I denote by I2, third one by I3. And the first two integrals easy to calculate by using substitution rule, which I explain here. In the first integral, I denote by u the sine phi, then du will be cosine phi d phi, and I will find the limits for phi when for u when phi is 0, u is 0. When phi is pi over 2, u is 1. We replace the integral with that values and we obtain u3 du. This is a very simple integral. Limit we substitute. After integration will be 1 over 4. In the second integral, we replace sine theta by v. Then dv will be cosine theta d theta, and limits accordingly change to the 0 and 1. You can see from this calculation. Then our integral becomes integral 0 to 1 v dv. The integral gives v squared by 2, which is the result 1 over 2. I3 is very simple. Rho 6 by 6, 6 cancel, then we substitute 2 and 1, which gives 63. Final answer is I1 times I2 times I3 will be 63 by 8.